Hello everyone, welcome to Equal To. I hope you have seen all the videos that I have previously uploaded in this particular chapter. So we have completed every single theory topic there, and here we are at the last set of in-text questions. This includes the last one and the previous one. So we have two sets of in-text questions here, and if you haven't watched the previous video yet, I will give you a link here. You can go and check it out first, because these questions are basically from that theory, right? Only if you understood that theory, you will be able to understand these questions as well. So I hope you have seen this. If you haven't, please go and check it out. Now we will move on to the questions. The first question here being, convert the following temperature to Celsius scale. Okay, we have already learnt a formula for this, that 273 degree Kelvin or 273 Kelvin is actually 0 degree Celsius. So the conversion is, you would have to subtract 273 from the Kelvin scale to get the Celsius scale, right? So the first question here is 300 Kelvin. To convert 300 Kelvin to Celsius, you would subtract 273 from it, which gives you 27 degrees Celsius. So that is the answer here. The second one is 573 Kelvin. So to convert 573 Kelvin to Celsius, you would obviously subtract 273 from it, which would give you 300 degree Celsius. So that is it. You just have to remember that 273 Kelvin is equal to 0 degree Celsius. Okay. So to convert from Kelvin to Celsius, you would subtract 273, and for vice versa, you would be adding 273. We have seen this already, right? Moving on to the next question. What is the physical state of water at part A of this question is 250 degrees Celsius, part B is 100 degrees Celsius. So part A, at 250 degrees Celsius, obviously water would be gas. Why is that? Because 100 degrees Celsius is the boiling point of water. So at 100 degrees Celsius, bulk of water molecules would get enough energy to convert into water vapors. So it become gas. And 250 degrees Celsius is way past 100 degrees Celsius, which is the boiling point of water. So obviously water would be as in vapor form, which is gas. So at 250 degrees Celsius, water is gas. Now at 100 degrees Celsius, this is where things get quite complicated, because 100 degrees Celsius is the exact boiling point of water. So at 100 degrees Celsius, some water molecules would remain as liquid and some would remain as gas. Water molecules that have latent heat would obviously be in gas form. Okay, molecules or particles that do not have latent heat would be in liquid. So both these have the same temperature. We have seen the concept of latent heat, right? The temperature wouldn't increase, but that energy is used to transform the state of the matter. So the molecules, water molecules that have latent heat would be as gas. Those do not possess latent heat would be as liquid. So at 100 degrees Celsius, water exists as liquid as well as in gaseous state. So this is the answer here. Now moving on to the next question. For any substance, why does the temperature remain constant during the change of state? Okay, so this is the exact question for which the answer is latent heat. I hope you remember the definition for latent heat. So it is the heat energy that is used to overcome the forces of attraction between the particles of matter. So if you start heating ice at 0 degrees Celsius, the ice cubes starts melting. So the energy that you provide is used to overcome the force of attraction between the particles of ice. So the temperature wouldn't increase. The temperature remains at 0 degrees Celsius up until every single bit of ice melts into water. Only after that the temperature increases. So this heat is basically disappeared. It doesn't show any increase in the temperature. So this heat, since it is being hidden, we call it latent heat. Latent meaning hidden. We have seen this already. So that is why the temperature remains constant when there is a change of state. The heat that you provide is used up to transform. In this case, for fusion, and in some other case it might be for vaporization as well. Okay, so basically latent heat is the answer. Now moving on to the next question, suggest a method to liquefy atmospheric gas. So what we know basically is that for a change of state, there can be two ways or two factors that influence the state of matter. We have seen this already. So what are these? The first one being temperature. Solid on heating becomes liquid, liquid on heating becomes gas. So, and cooling transforms it in reverse. So temperature is one clear factor that affects the states of matter. The other one being pressure. We have seen this already. So on applying pressure, we are trying to bring these molecules, bring these particles of matter closer together. And since we are bringing it closer together, they tend to have more attractive force. They tend to change in state and become more solidified or more closer. The attraction becomes stronger. So change of state also happens there. So to liquefy atmospheric gas, you can have a chamber of atmospheric gas, a cylinder of it, and you can give pressure with a piston. So this would liquefy gas, and you can also cool it, and you can do this simultaneously for a better result. While keeping the temperature cool, when you apply pressure on gas, it would easily get converted into liquid, and that is how atmospheric gas can be converted into liquid, that is liquefied. How is that? Reducing the temperature and by applying pressure. So this is the answer for this question. Now moving on to the next question. Why does a desert cooler cool better on a hot, dry day? So what exactly is a desert cooler first? Commonly we call it as air cooler. In our homes we have it and we pour water into it. We try to pour cold water into it, but basically water works. And this, what it does is, it sprinkles water on the outer walls of this desert cooler. It itself does this. Since it sprinkles water, like at the back side of the desert cooler, you would have probably seen there would be like a brown color mesh, which is quite moist for the most part. So it sprinkles water there, and that water evaporates. It gains energy from the atmosphere and it evaporates. So evaporation, since it causes cooling, the chamber inside this desert cooler gets cooled because evaporation happens outside. So it gets cooled, and this cold air, it is pushed towards you using a fan. So this is how basically desert coolers work. So by sprinkling water on the walls, the surface walls, and it gets evaporated, so that is why it causes a cooling sensation, and that is pushed towards you using a fan. So why does it cool better on a hot, dry day? On a hot day, evaporation is faster because obviously as temperature increases, the rate of evaporation increases. So on a hot day, it would be cooling better. On a dry day, why is it dry? We have also seen that the factors of evaporation, humidity is one of the factor of evaporation. So on a dry day, there would be very less humidity. So evaporation can also be faster. So two rates of evaporation, two factors that influence rate of evaporation is present here. One being temperature, another being humidity. So water is sprinkled out, evaporation causes cooling, and fan pushes it outside. So that is why desert coolers are cooling better. They have a better effect on a hot, dry day. And basically speaking, why would you need desert coolers on a cool day? You wouldn't even notice its presence, right? Moving on to the next question. Water kept in an earthen pot become cool during summer. Why? So earthen pot is something that they make out of clay. I think you would have probably seen this. Most homes, some homes, they use it to keep water, drinking water. So you take water out of it and drink, and it's cooler. We basically use this in summer. So why exactly is this happening? This earthen pot, it's basically porous in nature. Porous meaning it has pores. It has a lot of small holes in it. Not holes that are so big that it can't hold water, but very small holes. So what happens is water oozes out. Water tries to come out of these pores, come through these pores to the outside of the pot. Okay, I think you get this, because water has pressure, so it exerts on the walls of this earthen pot, and because of that it gets through the pores. When it gets through the pores, evaporation happens on the surface of the earthen pot by absorbing the heat from the surroundings, and it evaporates. The water evaporates. Since evaporation happens, the surface is cooled. The earthen pot itself is cooled, which causes a cooling effect on water. So how exactly is this earthen pot working? It causes evaporation. Since it has pores, water comes through that and evaporates. Since evaporation happens, there is a cooling effect, and that is how water is cool inside it. I hope you got this. Now moving on to the next question. Why does our palm feel cold when we put some acetone or petrol or perfume in it? Again, the same concept. Where petrol or acetone, when it is put in your hand or when it basically comes in contact with the air, it evaporates immediately. Okay, perfume evaporates immediately when it comes to contact with the air, and likewise for petrol. Since it evaporates immediately and also evaporation causes a cooling effect, you feel cool in your hand. You feel your hand getting cold, and also it might absorb energy from your hand as well. That is one more reason it causes a cooling effect. It absorbs when it comes to contact with the air, it evaporates obviously, but also since you are pouring it in your hand, it can easily absorb energy from your hand. It can easily get your heat energy and it evaporates, and that is why it causes cooling effect. Okay, moving on to the next question. Why are we able to sip hot tea or milk faster from a saucer rather than a cup? Basically the concept of cup and saucer. You are able to sip hot tea easily from saucer because saucer has a larger surface area when compared to the teacup. And as you obviously know, larger surface area means faster rate of evaporation. So it gets cold easily. It loses its heat very easily since the surface area is high. That is why we are able to drink it faster in a saucer than in a cup. So basically these questions are right after the evaporation topic. So most of these questions are based on this evaporation topic. Moving on to the next question. What type of clothes do we wear in summer? So there is basically two answers to this question. One obviously being cotton. This is something that we have already seen in the topic of evaporation. So cotton absorbs, in summer we obviously sweat a lot, and cotton absorbs the sweat. Sweat is basically happening to keep our body cool. Okay, and cotton obviously it absorbs sweat and it helps for evaporation. Since it absorbs sweat, it spreads it across its surface, right? So it's easier to evaporate this water. So that is why we wear cotton in summer. And also one more thing is that we tend to prefer light colors on summer. Light colors usually they reflect heat. Okay, they don't absorb heat. Dark colors on the other hand, they absorb heat. So we tend to prefer light colors and cotton clothes. Again, to discuss more about this deeply, you have to see the evaporation video. I hope you have seen this already, so you know these concepts very well, that cotton can absorb easily, and that is why we wear cotton clothes on summer, and we sweat a lot in summer, and sweat is basically our body trying to keep it cool by itself. Okay, that is also a form of evaporation. So I hope you understood all these questions. If you have any doubts in them, please put them in the comments and I'll get back to you as soon as possible. And see you in the next video. Bye for now.